So for every slide after this, we are specifically talking about what happens if lines are parallel and cut by a transversal. So if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So angle 4 is congruent to angle 6, and angle 3 is congruent to angle 5. This is if they are alternate interior angles and the lines are parallel. If the lines are not parallel, they would still be considered alternate interior angles, but they would not be congruent. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. So angle 4 plus angle 5 will equal 180 degrees, and angle 3 plus angle 6 will equal to 180 degrees. Please notice that angle 3 and angle 4 form a linear pair,
which means that they will also add up to 180 degrees.
If two parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. So if we look at angle 1 and angle 7, they are alternate exterior, and as long as the lines are parallel, then they are congruent. Angle 2 and angle 8 are another example. Angle 1 plus angle 2 will equal 180 degrees because they form a linear pair. Also note that angle 2 is congruent to angle 8. Since they have the same number of arcs, that means that they're congruent. If we use our substitution property, we know that angle 2 and angle 8 will be congruent to each other. So if I know that angle 1 plus angle 2 is 180 degrees, I know that angle 1 plus angle 8 is 180 degrees. So if I look at these, while we will not call them consecutive exterior angles, angle 1 and angle 8, and angle 2 and angle 7 will add up to 180 degrees. Here is our postulate for corresponding angles. We have already received the definition, but now we are turning it into an if-then statement. So, if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. And again, these different numbers of arcs mean that the angles are congruent. To summarize the content so far, we note that when two or more parallel lines are cut by a transversal, our angle relationships form numeric relationships. And those relationships fall into two categories. The angles are either congruent or supplementary. The congruent angles will be alternate interior angles, alternate exterior angles, and corresponding angles. Supplementary angles will be consecutive interior angles, also some exterior angles, and linear pairs. Please do not forget that vertical angles are also congruent, and anything that we have previously learned can be used to solve future examples. Here is an example of a problem you could be asked to solve. Please note the given information at the top of the page. Line S is parallel to line T, and line C is parallel to line D. We want to know all of the angles that are congruent to angle 1. Since line S is parallel to line T, we can find that angle 3 is congruent to angle 1 because they are corresponding angles. Angle 6 is congruent to angle 1 because they are vertical angles. So vertical angles is something we learned about in chapter 2, and we still will use it for the rest of the year. We also know that angle 8 is congruent to angle 1 because angle 8 is alternate exterior with respect to angle 1. But please note that 8 is also vertical with 3, and 8 is corresponding with 6. There is often more than one way to get to the answer we need. Angle 9 will be corresponding. Angle 14 is going to be alternate exterior.
Look at example 3. I can see that this only has one measurement. And if I want to find all the missing measurements, I'm going to start with what I know. I know that this angle is going to be 42 and that these are going to be congruent because they're vertical. that these two angles are going to be congruent because they're corresponding. I know that these two angles are going to be congruent because they are alternate exterior angles. But now the next little bit of work I am going to show is how to find the other angle. And I simply would take 180 minus 42, and I get 138. That lets me know that this 42 and this space right here are a linear pair, so that's going to be 138 degrees, which means that this is going to be 138 degrees because of vertical angles. And then again, I go through the same pair because of, let's say, alternate exterior angles or corresponding angles. This angle right here will be 138 degrees. And therefore, because of alternate interior angles or vertical angles again, this will be 138 degrees. And it may seem overwhelming because there are so many different options. That is why it is so important to show your work. And when asked for a reason, you give it so I can see as the teacher which method are you using. Our last example has to do with right angles. And if we remember from chapter 2, we know that all right angles are congruent. So if this angle is a right angle, then we know that the measure of every other angle at this intersection is a right angle. And because these are two parallel lines cut by a transversal, using corresponding angles, I know that that angle is 90 degrees. Then I would know that every other angle is 90 degrees. We also have examples that involve algebra. In this relationship, in this example, I am given these two angles. I can see that they are alternate sides of the transversal in the interior, so that means that these are alternate interior angles. And I know that alternate interior angles are congruent, so to write this equation, I would say 3x minus 3 is equal to 2x plus 20. Once I set up the equation, you should be able to solve it. Subtract 2x from both sides. Add 3 to both sides, and we get that x is equal to 23. If the question just asks us to find x, then we are done. However, if the question asks us to find the measure of the angles, then we must substitute, and we get that the measure of each angle is going to be 63 degrees. Whether or not I need to substitute is determined by the question that is being asked. In this example, I can see that there is no relationship between the x minus 97 and the x plus 15. However, I can use corresponding angles to move the x minus 97 down. And then I can use a linear pair to see that these two angles will add up to 180 degrees. So the equation that I will set is x plus 15 plus x minus 97 is equal to 180 degrees. And then from here, I would just use my algebra skills to combine like terms and solve. And I get 2x is equal to 262. I divide by 2, and I get 131. And then, depending on the directions, will tell me whether or not I need to substitute. So we are going to substitute here just to make sure that we thoroughly and completely answer the question. So I would take 131 plus 15, and I would get that this angle is 146 degrees. And then I would take 131 minus 97, and I would get that this angle is 34 degrees. Why is that important? Because now I can check my answer. Just off to the side, 146 plus 34 Well, that is equal to 180 degrees. My answer makes sense mathematically, and I know that I am correct. If we look at this angle, we want to solve for x and then find the measures of both angles. So the first thing that we want to do is to determine how this angle and this angle are related. And we see that they are alternate exterior, and therefore we know that they are going to be congruent. So the equation I will set up is x is equal to 3x minus 120. And when I solve this, I get 120 is equal to 2x. I get x is equal to 60, and then I substitute. So the angle is 60 degrees, and then 3 times 60 minus 120 gives me 60 again. Both of my angles are congruent. I know that I am correct. I'm going to go through some examples and show you how to set them up. If I look at this example, again, this is a right angle, so we know that all of these are right angles. And since this is alternate exterior, we know that I could set this up by saying 2 minus 80 is equal to 90. You would then use your algebra skills to find x, and then substitute to find the missing angle. Except in this case, we already know the missing angle is 90 degrees because when one of them is 90, they are all 90. In this example, we see that these angles form a linear pair. And we know that a linear pair adds up to 180 degrees. So I would say x plus 20 plus x minus 15 is equal to 180. And again, you should know how to solve these problems at this point. Please note that while they don't happen often, decimals do happen, and it does not mean that you made a mistake. There is not an listed or named relationship, but if we remember back to the earlier in the video, we know that these will be supplementary, and therefore I know that x minus 15 plus x plus 25 will equal to 180 degrees. If I look at this example, I know that the angles are corresponding, and I know that corresponding angles are congruent, and therefore I would say 14x minus 1 is equal to 12x plus 19. You being able to set these up depends entirely on knowing the relationships between the angles. This example shows that these are consecutive interior because they are between the two parallel lines and they go one after the other. Consecutive interior angles add up to 180 degrees, so it would be 147 plus 2x minus 23 is equal to 180. And again, you would use your algebra skills to solve this problem. For number 7, there is no mathematical relationship here, so if you remember, we have to use what we know about other relationships. I can choose to bring this 3x minus 15 down using corresponding angles, and I would use corresponding and then a linear pair because they add up to 180. Or I could move this 2x up and I could use a linear pair at that point. I could also, if you really wanted to, move the 2x to here using alternate interior angles. I could move the 3x minus 15 to this location using vertical angles. Either way, I'm going to be adding the 3x minus 15 and the 2x and setting it equal to 180. Since there is often more than one relationship that allows us to get to the correct answer, it is very important that you provide support and state what angle relationships you use to set up your equation. Please don't forget to bring any questions you may have to class.